problems, you have to take the 3 class period because it due to a few things. We take a look at what's the problem again, review a little bit. So basically we have a truss structure and have load and 200 pounds. This is wood structure, have the fixed support at the left and the simple support at right. So we work out all the way and obtain the reaction force at supporting simply support and fixed support. So now we work on the internal force and also the stresses for each member of the truss structure. Your homework assignment, the next one, first problem is similar to this. Okay, just have a little bit of load change. Other things, entire solution process is similar to this sample problem. Last time we work out the internal force for the element 1, and this is element 1, and so basically we transfer back from global result back to the local and use those formulations, and then we will have displacement obtained for this element. Then using the spring force equal to the stiffness times the deflection, we obtain the internal force. Okay, this is internal force for element 1 in the actual directions of local coordinates. Then we're using the formula, and this is a strain times the Young's modulus, we can get a stress. So this is stress we calculated last time. To do a cross-check, we understand the stress times the area should be equals to the internal force. So F1x should be equal to the sigma 1 and A, because the cross-section area is the same. If you do a calculation and use the value you will find, I give you a result 141 and 141 and 0.52 pound. So if you do a checking, the way you use the stress calculated, the way you use the Hooke's law calculated, exactly same result. So which means your solution process is correct for the element 1. So now we repeat this process for the element 2 and 3. Then we will done with these sample problems. So for element 2 next. And repeat same processing procedure. So we have local coordinates, and the local coordinates we have to first mark them down. So global one, we have this is X, and this is Y. So for local, for second element, element 2, so we have element is go this way, and this will be U2 X. Sorry, my drawing is a little bit off. Okay, so this is a U3 X, right? So coordinates local one will be, this is lowercase y, this is a lowercase x. So this is node 2, element 2, node 3. So this side, we have internal force F2x equals to the K2 and U2x minus U3x. Likewise, this side, and we will have F3x will be equals K2 and the U3x minus U2x. Okay, more detail for this element, we have theta equals to negative 45 degree, or you can use they should obtain same result. Just have the some sign convention you have to follow. Be careful that part. So changing to the local for displacement. Here we don't have the node 1 information, so this is why when you write down the displacement, you see the node 2, node 3 only, and the 2 direction. So due to the 45, substitute to the equation before we use this one. Okay. So we will have cosine sine 45 will be the square root over 2. Be careful the sign also. So we have 70. If we change that to the decimal point, and 0.7071, this is 0, 0. And likewise, 0, 0, and this will be 0, 0. And copy down again. This multiplication matrix with displacement we got from global. So we have 16.779 and negative 64 and 1719, sorry. And so 33.557 and 0. Each member times 10 to the negative 5th power. If you do a calculation, you have to save time. I give you result directly. 57.24 and negative 33.5118. And the third one, 23.7282 and 23.7282. So times 10 to the negative 5th power unit is inch. So this is the deflections and for those nodes and for that element. And next, we will do similarly the internal force calculation based on the local deflection value. And also, we will do the stress calculation for element 2. So similarly, I will have F2x will be equals to K2 and U2x minus U3x. If we substitute the value inside, we have 141.5 5, 2. And similarly, for sigma will be Young's modulus times string u2x minus u3x over total length for that element is L. So we give the number here. And will be the 12 times the 3, 32, or 36, sorry. So, and we will still have one more term. We have that 10 to the negative 5th power. If we do calculation, give us 100 pounds. Oh, sorry, I copied it down wrong. So when you do calculation, or better we do the checking. 17.69. Okay. Likewise, you can do the checking like we did before, and you will find it will give the same result. We do not need to repeat that. So next we take a look element 3. So this is the global coordinates for element 3, and also local coordinates, global coordinates is same now, because element 3 is horizontal. So we will have u1x. This is a local, x lowercase, y lowercase, and element 3, and also we have node 1 and node 3. Here we have u3x local. So fourth, this side we have 3x equals to k3 and u3x minus u1x. Yeah, straightforward. This side we have f1x equal to the k3 and u1x minus u3x. Those are very similar. So sigma 3 and also the fourth, we can do the calculation. We'll have k and times u1x minus u3x, and will be 2.98 times 10 to the 5th power. And then we have that deflections. And if we, oh, sorry, I missed the steps. We're supposed to get the deflection first. Okay, sorry. You can keep this line of writing and back up later. So we have, again, local one, u1x and u1y, u3x, u3y. And will be equals to that matrix, transformation matrix. Since it's 0, everything else is 0. Only the diagonal term is 1. because the diagonal term is cosine, 0 will be 1. Unit matrix times the displacement from the global. You can check back the solution from previous global one for U, and now put it over here. So at top, after multiplication, so easy for us because it's a matrix of unit. We'll have this result. Then we do the force calculation. So the previous line of writing, you can now continue from there. So F1x will be the K and the 3 and the U, 1x minus U3x. So we have 2.98 times 10 to the 5th power. Copy down the 0 from that solution. And the minus will be negative 33.557. And if you do calculation, give us 100 pound. Likewise, we can do a checking. The sigma 3 will be equals to the E, then times strain over total length. This is the longest side of this structure. So we have 0 plus, because the negative becomes a plus, 33.557, and over length of the bottom element 3, will be square root 18, and is feet, converting to the inch. If you do a calculation, give you 12.523 and the PSR. If you want to do the verification, and for F1x, like we did for element 1, you could. It will give you same data result. So F1x equals to sigma 3 times A. If you check, it will equals to 100 also. Now we finish entire problem. You see, very lengthy, very long. And we only give you one problem to solve it. For the homework 6 is problem 1. Will be the very similar to, a little bit different is those two loads have an angle. Okay. So after you're done, usually you have to do the verification, use the statics concept for truss structure to make sure your solution result is correct. For example, for this one, we can do a quick check. Use the entire structure. What you check is check the reaction force. And we know for this structure, so basically we have So this is 45, 45. So we have 1, 2, 3 for node. Okay, so we have global coordinates. So using the static equilibrium, so sigma f for reaction for equal to 0. And so we will have 100 plus 100, 2, right? Minus 200, because we already figured out the number. That indeed equal to 0. And yeah, it should be sigma y. I write down sigma r. Sigma y, sigma x equal to 0 because there's no force. And you also can use a moment to do the verification, and it should give you same result. Say you take the moment about the node, should be equal to 0. You can verify that way also. That's what we have for these sample problems. And you have a chance to repeat the same solution process for the first problem in homework assignment 6. Okay. A little bit tricky is load. Load is not exactly vertical, if you take a look. Okay. Any questions, discussions we need for this problem? Any questions? Very long, you can see. And your solution for that problem were very similar. In case you find is calculation is quite a bit involved, I encourage you use either MATLAB or spreadsheet. Yeah, that way, guarantee you produce a correct result. Don't manually do the calculation. Sometimes that will trigger the errors, and then they make you puzzled, spend a lot of time doing the calculation rather than the problem itself. And also recall what's when you do understand this process. Any questions? Okay, if no questions, what we're going to do next is do the lab. Please log on to your Ansys. So we start from there. Then once you click the workbench, I already start mine. It'll take a few minutes. It's very slow, our network, somehow, I don't know why. Now, since we already learned a few times, we can do, once you have this startup, make sure everyone has this. Then we'll proceed from there. Otherwise, if I speed up at one of the loss, you lost volume. Then the quick static structure. Double click. So once you have that, click geometry or do sketching. Creation of the truss structure is a little bit tricky inside of the Ansys due to the nature of the truss itself. Once you have this start, and so we inside the design DM, the design modular. So you click the XY plane and make it 2D. Use a look at. Right mouse click, you will see that and look at. You also can use the 3D orbiting. Either way should be fine. Once you have that, we can start the sketching. And you click sketching tab below the toolbox. So now you will see the draw and modify dimension, and click you draw, you expand those sketching feature available. Once you have that, click, you see the polygon. The default had 6 sides. Change that into the 3. Make sure everyone follow. Right mouse. No, just right mouse. Look at it. Okay, now is you can sketch of the stage. And the polygon. Don't place anything. Just follow. Okay, before you place, take a look at what's scale. This is 30 meter, pretty big. Okay, more like a bridge, that type of thing. So anything 30 meters is like this. Okay, so anything you create over there is a pretty large size. We will start. Now we draw a triangle. You do. Make sure your triangle bottom portion is horizontal. Then place it. Okay. Next, use modify. Once you create that, click modify tab. Then you will see copy paste. Click copy and select your triangle. Once you're done, the triangle is you created, just select it and say paste. You see your cursor will have a triangle attached. You try to coincide this point, possibly not easy. That's fine, we can figure out the way to do it. So that way you place 1. Oh, I placed more than 1. I have to delete the other one. 2. Then you can either AND or use escape key, either way. So you can use AND or you can use the escape key. Okay, so we don't need this one. So the one we don't need, we can delete. So make sure you have 3 triangles, exactly same size. Good. Yep, good job. Yep, good. You have to do the paste. Select all of them, then go to the paste, modify. No, you have to do the copy, then select the triangle. And then do the paste. No, you paste. Yeah, no, you just use that paste. Yeah, that's fine. You pick. Then after you have the 3 triangles, then use this and X, or you can use it the N. Yeah. Not worry about size because all in there. Okay. Next, what we'll do, let me try to do this off. Possibly difficult for this, but that we have to see. So now you can zoom in. You see those 2 points is not at the same location, right? What you do is we're using the pen to move this little bit. Then you go to constraint. You see that tab, constraint. You see this coincident. Yeah, slow down a little bit in case you have problem. And click it. And choose the first one. Choose the second one. They will move together. Likewise, apply this to the second, between the second and the third triangle. Oh, not selected. Oh, my case somehow. Let me just, yeah, there is an accident happened when I do the constraint. Okay, let me just delete this and redo it. Yeah, you can work on this when I correct mine. Okay, next we do the constraint. We have to zoom in to clear see this one. And this one, oh, still not constrained yet. A little bit sensitive. Oh. Undo, undo, undo. Okay. You see, my cursor selection is a little bit sensitive. It will somehow not select correctly. Go. This one. Good. So you do same thing, possibly majority we already done. In case not yet, you can take this time. And I use my office computer because this laptop could not do the, I have to use an office computer to do the recording. And do same thing for this two. No, point, but not a line. Point. Very sensitive is, oh, point, okay. Point, okay, yeah, sorry. So somehow. Now next, close the gap at the top. You go to the Draw tab and select line, and you can do a setting and go to the grid. You can show grid and use the snap. Okay, that way when you approach to location of the for the top point of that triangle, you won't have problem. Okay, you go to here, you see, you're supposed to see a rectangular show up, a square. So you draw that line to here, you see that H show up and also the other rectangular or the square show up. Do second line. I have to see that square show up, place. That's it. Then we create basic sketching. So now we have basic sketching. If you click the model tab now, you can see you have a sketch one over there. Okay. Of course, you can move this, center this, and so easy to see. Okay. Now make sure everyone have this. You have sketch one and create it. Yeah, excellent. To be same, if not, you have to redo on your sketch. Otherwise, later on you have to create the truss structure. Because Ansys is not CAD model, so it's not very good. You just copy paste. You don't create the same. Just copy, use the first one, copy paste, 99% of students on the same step like I showed here. Okay, sorry, we just use a little bit. You will get, let me see what's best. Possibly we still need about the 10 minutes. We should be, 10 to 15 minutes we should be done. I don't want to stop. Then we have to review back. Okay, so now next, when we have this sketch, so then we can do is select it. Yeah, use your cursor, select you select a sketch, right? And now you go to menu bar and call the concept. So from that drop-down list, you see last one, cross-section. Now we need to create the truss structure. And you're using rectangular tube because we'll use a tube create the truss structure. Tube, rectangular tube. I slow down. Yeah, that way you see my process. Click. Then cross-section of tube will show up. You see this is tube, rectangular, basically square. And define the W1, W2 as 0.25 meter. Be careful. Pretty big. 0.25 meter. And the enter key, you will have that defined. Thickness, T1, T2, T3, T4, just use the default. So no change to them. Now, if you check back, you will see you have a cross-section and the rectangular tube one created on your tree list. On here, your tree list. Yeah, make sure you follow. Everyone follow? How about you guys? Yeah, make sure you follow. How about Stephen? Okay, you guys. How about you guys? Good? Okay. So next, once you have that, okay, you need to follow me. Now you select that sketch again, go to the concept. Okay. Now you see from the top, down second one, line from sketch. Click. Then you will see the change. Okay, this will show up. You will see have a line 1 show over there. Now we create solids. Yeah, this process basically is create solid and use CAD features. Okay, so then you have, now you're just using the apply button, apply. So once you've done that, you see you need to update line 1. Yeah, that you use to create your structure, your body. So right mouse click, you will see generate. Now you generate truss structure base model, base body. If you do orbiting, 3D orbiting, yeah, use this one, or rotation, you will see that. Once you've done that, you will see your body is created at the last. So you can see a line body. You click that line body, this one. Yeah, the process route is a little bit hidden, so make sure you follow me each steps. Once you select that, you will see your cross-section ask you to choose is highlight. You go here, click, you will see this. Then there's a drop-down list. You see your rectangular tube 1 is over there, and click. Then that cross-section apply to your structure. Yeah, make sure you follow. I slow down here intentionally. Okay, now you can see your body, your solid. You go to the view at top, cursor here, view, and click, and cross-section solid. You click, solid will show up. So now you're done with the creation of your truss structure. Now we have to do the FEA part. Okay. Yeah, make sure you go. We can help most of the students. In case you lost some steps and the repeat, we have a chance for you to repeat this. I think you have an assignment. You can do this. Now we have this. We go back to this one. You have 2 windows at the bottom. This is modeler. You go to this one. Go to the home window. So now you click model, double click. Now we go to the mechanical window. So you can toggle between the wireframe and the non-wireframe. You click here, you see this is a not wireframe. If this is a wireframe, it will show you. Okay. And the next step we will do, you see the mesh, that icon is yellow. There is a flash over there. And you click mesh icon. Bottom will have the information show up. You see the element, the sizing. You see sizing, expand sizing. You will see element size. Slow down a little bit in case you see this. And change that size to 100. Default, you click default. And type in 100 is a millimeter, very small. Then the Enter key. That's it. That's what you do. You can change various size of the, but for this structure, what we currently use is 100 will be more suitable size. Now next, you go to the mesh icon again. Right mouse click, you will see the generate mesh. That click, you see the calculation. Now the structure changed into the FEA model. Yeah, I want to make sure everyone. Sorry, we have to put a little bit more time. This is the very important. Good, excellent. Oh, still in the calculation. Excellent. You have mesh. Yeah, excellent. Now this is a G steps. Remaining will be very similar to the previous map. Excellent. Once you have that, next what we're going to do is do the mechanical stuff, because now is the mechanical stuff. And mesh will be generated. We have FEA model set up. So next is apply the boundary condition and also loads. You did this already. So what you do is go to the static structure icon, and the right mouse click, you have insert. So first we insert fixed support at the left-hand side. Okay, you click that one. So ask you select a place at the bottom. We use and the vertex selection. You go to this one. You see my cursor at top. You can select face, edge, vertex. Vertex was suitable for this. Okay, you select a vertex and push to here. That point, you see it will highlight. It has a vertex selection. And select, say apply. You will see the support is applied. Okay. We repeat the same process, and we give an over-constrained structure for you can try not over-constrained. Okay. So second one, select this one again. Right mouse click, insert, and we do another fixed support at this side. Click and apply. You have two. If you click this, you will see you have two support. Excellent. Yeah, excellent. Excellent.
Do you want the point or you want the edit?
No, you use the vertex. Oh, the vertex. Okay, excellent. Excellent. You click here. Oh, yeah, excellent. Okay. Okay. You follow, right? Okay. Next, we apply load, two load. And first one is a load at this point, and the second one is load at this point. This load is horizontal to the positive directions of x. This load is vertical to the negative directions of y. So now we take a look how we do that. You already did this before and for different lab activities. Now you go to insert again. You see force. Click. Then you see highlight. And we don't use vector. Vector is a little bit tricky because the cursor selection is very difficult sometimes. We're using components of force. So you see x, y, z, and 3 direction. We try middle point, this point first. So that will be y. We give negative 10,000 Newton. Make sure you have 4 zeros. Okay, enter. So now we do selection, you still wait for selection, and that's the point we selected. So now you say apply, you see force applied. Repeat this for the top left point. Apply a horizontal force. So go to insert and the force. And again, use the scalar format, components format, and components. That will be in the x directions, 5,000 Newton. Enter. And next point, we try to apply. You see? Then the force applied. If you select structure icon, can you see the load and force, all of them are applied. No, excellent. 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 Do you have all of them?
Yeah.
Excellent. Do you have load applied? I have no, you have to select that force. No, you have to change the vaccine. Find that x 500, 5,000. Okay. Yeah, we're almost done. So I believe that after this, you will be good to do by yourself. Next, what we need to do is the deflections and also those FEA mechanics material stuff. First one, go to the solution. You can do either way. You can do the solution first, solver first. You also can do the insert, those deflection and stress, up to you. So we do solution first. You can see now that is K matrix times U matrix equals to load. Now, if you click that solver, that's Ansys help you to obtain the U values and reverse the K matrix, basically, very huge. Now you click that solver, you see the calculations going on here. This is the solver window. Once that update, you go to the solver window. Okay. Then the problem is the Governing equation is solved. Now we can obtain those information we need. The first one, we get the total deflection, deformation. You click, insert, wait for you to update. Second one, click solution, and choose beam results. We want to get an axial force because this is a truss structure. We want to know what's each member internal force situation. Third one we can take a look is a bending moment because it will take vertical and horizontal load to cause a bending of entire structure. You see the bending moment. Okay, we have those three. Wait for the update. So now you go to the solution and do the evaluation result. It will evaluate. Do also the post-processing calculation. After that, if you click any of those, it will show you result. Okay, for example, for total deformation, and we can see AV clips. Now this is very similar to the previous one we did. The challenging part for the truss structure is how to create the structure itself. Excellent. Now we take 20 minutes break, then we back with the presentation. You only have one. You have two. Yeah, I did. Yeah, that's fine. That's fine. But when you do this, you are needed to update, we change the yeah, I could solve them like that one. Try to be more honest than you would line body. And once you go here, you select your pendulum. You don't have that one. You have to pay with that one. Okay, we take break and then back.
Drop your phone. I had a question on the test. The last problem, you marked me off for not having C. Did you want the equation? Because I have it right here. I just
I saw your answer because you have to do the calculation also in the base equation.
Okay.
Usually this will be the 1 point to box. The reason we only do this is if you have number here. No, this is the one.
Okay.
You should have this expression because of the answer. We have the approximated equation here. So then when you have to substitute everything inside of the
that makes sense.
before you do it, you use the number.
Okay. Thank you.
Yeah, go ahead.
Oh, yeah.